logarithms. So logarithms are used normally to also get rates. So maybe you want to look at the growth rate of a certain country, you can apply the log of it to get the rate. So you can get rates, growth rates from GDP probably. Then we have different outlines here: introduction to logarithms, properties of logarithms, exponential and logarithms function. So now on this slide we have for instance, how many fours do we multiply together to get 256? So the question, or the answer to this question is that we have to multiply 4 by itself 4 and multiply it by itself until we arrive at 256. So this simply means that we have to multiply 4 by itself 4 times in order to get 256. So this kind of logarithm is the base 4, because 4 multiplied by itself 4 times to arrive at 256. So the logarithm of this is base 4, which when we take it, like when you use your calculator to take the log of 4256, you have 4. So when you punch that in the calculator, you get the same answer. So, like many types of functions, the exponential, a number representing the power to which a number is raised. That is, for instance, you can have 23 to the power 3, where the exponent is 3. So, function is the inverse of. So, when you see any exponents, the exponent is the inverse of the logarithm function of that exponent. So we'll discuss this later in this session. Yeah, so we have this logarithm where we have 10 raised to the power 2 is equals to 100, meaning that 10 has been multiplied by itself twice. And because it has been multiplied by itself twice, then the base of 10 is 2, because 2 was multiplied by itself twice to arrive at 100. So again, when we take the logarithm of 10 of 100 on our calculator, you will get 2. So there are common logarithms. There are also methods of logarithms which are considered in this form: power 2 raised to the power 0, 2 raised to the power 1, 2 raised to the power 2, 2 raised to the power 3, up to a certain number. So in this case, we have it as a base 2 for logarithm between 1, 2, 3, 4, 5, and 6. Now, logarithms have certain properties, as we've seen in exponents. So, for logarithms, the following properties you come across is: number 1, you say since a raised to the power 0 is equals to 1, and a raised to the power 1 is equals to a. So it means that when you get a logarithm of a raised to the power 1, it will be equals to 0, because whatever you raise to the power a here will give you 1. Now this is also an inverse of the exponent. So the inverse of that exponent is what we call the logarithm, which when you take the inverse of this, you will arrive at log a of 1 is equals to 0. And the same thing applies for property b, which is when you look at the log of a. The log of a will be equals to 1 in the reverse order of the exponents. So the second property is that since ax and log of ax are inverse, as discussed in 1, then property c is that log a of ax will be equals to x when you take the inverse order of it. That's the second property. Then the third property is saying that since a raised to the power p and a raised to the power q is equals to a equals to p plus q, which we have discussed in the former slide, it means that we can also take a raised to the power p over a raised to the power q divided will give you a raised to p minus q. So that also represents property 3. So within the property 3, we have property E and property F. For this one, you will just take, because the product of a log, then we take the log of each of them and add them together. So in this case, we'll be having log A of P plus log A of Q, which is the same as log A of P divided by Q is the same thing as log of A P minus log of A Q. So these are simple properties of logarithms that we must know, so that when we are dealing with logarithms, we can equally do them without any issues. So examples of the application of these properties of logarithms are seen below. So you can see in an example 1, we have log 510 plus log 520 minus log 58. So the answer is, if there's a question mark here saying what does this all represent? So if you go back to this function where we have this raised to the power a plus b, then it means that we can divide this by this to have that answer. So if you look at this, you see that this can be said to be log of 5 into 10 times 20. Or you can say this can be log of 5 of 200 divided by 8 and all that. So for further reference, look at the study session 3 in the PDF for further reading, and you see more about what you are saying.